Hello, I'm MC Toon, and it's Toon's Day night, and I'm excited. I had to delay this an hour because I had some other stuff. Thank you for tuning in. Tuning in. Note how I spelled that when I said it. I have with me tonight a maybe flat earther, Chris Curtis, and we have Gary too. And hold on, it's coming. I got it. All right, here we have Chris. Chris on the bottom, Gary over on the right side. How are you guys doing?
We are doing well here.
I'm amazing, man. I'm glad to be here. Thanks for having me.
Yeah,
Yes.
thank you. Like, very happy to be here.
So Gary and Chris. So Chris wanted Gary to be here. Gary has it's I think it's a little late for him. He has to go in a little bit. So I thought we'll have some interaction focused on Gary here to begin with. But I know, Chris, that you wanted to present your flat Earth model.
Yes.
And you said 7 minutes. Maybe take your time, do it in 10. If you
I can do it. I can do it really, really fast. Can I share my screen?
Yeah, give me a second. I gotta enable it.
Okay. All right, cool. Oh,
All
hold
right,
on.
yeah, go ahead.
All righty. And hold on, I gotta figure out which one I'm. Oops. Can you see it?
Nope.
You can't. Hold
yeah,
on, I think I might have forgot. Can you see it?
Yeah, hold on. I need to arrange it so people can see it because it's way too big. But yes.
Oh, my bad. Okay.
No,
so
that's on me.
Well, you can follow along because I put together a website. I didn't have time to finish it today, guys. I apologize for that. But you can go to parabolicearth.com if you want to follow along and look at all of the scripture I have here to support my hypothesis on flat earth. Again, I'm a flat earth proponent because I believe the Bible is true. And I know that there are different ways to look at it. I know that you can interpret it in different ways. My friend Gary and I talk all the time. Michael and I bug Michael all the time and ask him stuff. But I believe that the scripture is true. I believe that God's ways are higher than our ways, that we don't really understand the extra physics that go along with the heliocentric or with the model or the actual model that we're living in, not the heliocentric model, according to me. So when we look at Genesis, one of the first things, something profound popped out at me today that I wanted to bring up, and it was when God brought the earth out of the water. God brought all of the water together in one place. And that was profound to me because if you take water, which is hydrogen and oxygen, and you break it apart with the hydrogen, what it's telling us, according to the Bible, the way that I interpret this, is that oxygen existed before helium, right? Because if you bring that water, if you bring that hydrogen together in one place, to me, that's talking about fusion. And 90% of the elements that exist in the universe exist from hydrogen, and the rest are from helium. But you can actually create helium with hydrogen, and you do that through fusion. That's the way that it's described in the process of stars. You have this fusion reaction that happens, and as a result, you have this massive release of helium. So a lot of people will say that the Bible is not a science book. I completely disagree with that. I think that the Bible definitely is a scientific book. It tells us that everything we see is made from the things which we don't see. It tells us that the stars are as innumerable in the heavens as the grains of sand on the sea. James Webb has just showed us that you can literally see when you're looking up at the sky, when you're looking up at the stars, you can see the sea. That is what it looks like. It looks like you're walking on the beach. The thing is we didn't have the optics to be able to determine that until recently. So when you look at what the Bible says, when you look at the things that are in it and you read it and you look at it based on the knowledge that we have, I don't find any contradictions. So when we're thinking about God creating the earth, one of the first things that he does is he creates the firmament. Can you guys still hear me okay? Am I coming through okay, Michael?
Yeah, we're listening.
Okay, great. So one of the first things he does is he creates the firmament, right? God is above the water. I don't imagine that God is above the earth. That's a ball. And the reason why is because if that was God over the earth, that's a ball of water, that makes God an alien, right? And when we look at probability, the probability for a single protein, for instance, Gary, you and I have talked about this, the probability comes out to 10 to the 164th, which is an exponentially hard problem when you only have several billion years of the universe. You know, I mean, you can take the oldest things that we can measure, whether it be uranium, plutonium, you know, the things that we know have half-lives of billions of years, and it doesn't give enough time for all of this protein structure and the mechanism of life based on probability to form. So what that means to me is that God exists beyond the cosmos that you and I inhabit. In other words, God resides in higher dimensions beyond us. And when we look at the firmament was brought out of the water, or it was in the water because it protects us from the water above and the water below. Many people will look at the firmament as a dome. I look at the firmament as a sphere that resets in every direction. So again, you have God above the firmament, you have the water below the firmament, you have the earth being created in the water. Jesus is, according to the scripture, I'm in this for the Bible, he is the word of God that was made flesh. He said in the Garden of Gethsemane, Father, glorify me together with thyself, with the glory which I had before the world was, meaning he was raised as the word of God. So when we look at the firmament in the water, again, it's not a dome, it's a sphere, it's in the water. When God flooded the world, he opened up the windows of heaven, the water came down upon the earth. But I don't look at the firmament as necessarily a solid structure like, you know, we would imagine a barrier that's protecting us from the water. The way the firmament works is it is a barrier that exists. It's wrapping us inside of the fifth dimension. And this is because God exists in higher dimensions, right? He's beyond us. And if we have an extra dimension of space, we have another axis that we don't have access to, right? So if God is adding the firmament, then the firmament is preventing us, it's preventing the water from, you know, entering the earth. It's also preventing us from going beyond the earth, right? And if you look at, if you're going to think about extra dimensions, to me, you have to look at the dimensions that we can see and recognize. And all we have is the three spatial dimensions that we inhabit, right? So if you look at the first dimension, to me, it's the highest dimension because it contains all of the probability for all of space on the Planck scale, which is the smallest unit of measurement there is. All of that probability, that point can only exist in one point. So there's obstruction in the first dimension. But
Uh-oh, we lost him.
Your audio, hold on.
Can you hear me?
Yeah, something went weird on your audio.
Oh, it's the government.
Probably. Yeah, it's always.
Yeah. So did you guys lose me, or are we still?
No,
No, we can hear you again.
one sentence, yeah.
Okay, cool. So when we're thinking about the dimensions that we can see, one dimension is obstruction, right? I can't move beyond my single point in space. When I add a second dimension, like a flat surface, I no longer have the obstruction because now I can color in space, right? There are no walls. There is no obstruction when I have 2D space.
Did you say you can color? You can color in space?
Yeah, because I can connect. I can connect things on 2 dimensions, right? Like a piece of paper. If I was to draw on a piece of paper, there are no walls. There is no obstruction in 2 dimensions. So the second dimension would be a lower dimension, right? Because it's taking the obstruction away from the first dimension. When I add that extra axis in the third dimension, I'm adding space, but I'm also adding obstruction, right? This is what we can see. And when I access the third dimension, now I'm able to fold a piece of paper, right? I can fold a piece of paper in half. I can fold a piece of paper like a paper towel roll. There are a lot of things that you can do to manipulate things because you have the obstruction. Without the obstruction, you don't have an object to manipulate. The fourth dimension is removing the obstruction in 3D space, right? Because that's what we see with the second dimension from the first dimension. Now I would be able to color in 3D space. So what that means is I can walk through walls, right? Jesus walked through walls when he rose from the dead, which means that he was able to, in my view, the way I see it, access that fourth dimension.
The fourth dimension in our terminology is not a spatial dimension, it's a time dimension.
Okay, we're not
so, you know, if you apply the fourth dimension to a three-dimensional system, a Cartesian coordinate system, for example, you have motion, you have dynamics. That's where we get the dynamicism of our 3D world with the time dimension.
Absolutely. Right? And I'm talking about spatial dimensions. So as I add space, I'm changing time. Because now what I can do in the fifth dimension, because I'm adding an extra axis, so perceiving the fifth dimension would be like perceiving the third dimension from 2 dimensions. It would be impossible to actually perceive. And mathematically describe, right? It's kind of like dark energy. This is where I think that you and I are on the same playing field. But since I'm adding that extra axis, I'm adding the obstruction. And based on what I can see in the lower dimensions, I can fold 3D space like a piece of paper.
Mike, are you grasping this concept of obstruction that he keeps
No,
saying?
the obstruction thing is I'm not getting the obstruction thing, but hold on, this might help. All right, good. Keep going.
I wish I had.
Obstruction is a wall. Right, I can't go through an obstruction. An obstruction exists in 3D. It wouldn't exist in 4D, but it would exist in 5D, which would allow me to fold 3D. But because it's wrapped in 5-dimensional space, and I need to see through the reset sphere, because when I look up at the sky, I'm looking below the Earth. Right, I'm looking under the Earth, and the book of Enoch says that the stars and the sun and the moon, he was looking down on the chariots of the sun and the moon and the stars that run along the ecliptic, and he saw the circumpolar stars in portals below that. So he was looking down from his perspective on those things. The book of Job tells us the sky is like a mirror, doesn't say that it is a mirror, right? And that's why I use a parabolic mirror in my demonstration, because if I'm looking through the sky and I have the sky being a surface, let me scroll down a little bit. ParabolicEarth.com, by the way, if you didn't hear that. I made this for you, Mike. I colored it yellow so you could see the Pac-Man. But if you'll notice here, this is the four corners of the Earth. Right? Okay, let me go over to this one. Okay, so the 4 corners of the Earth are around the circle of the Earth. These are where the 4 angels are standing.
Wait, where are the corners on this round thing?
Okay, this is the round thing, and it sits inside of a square.
Where's
right? You don't see this.
And why did you choose this? Wait a minute. What is this yellow area supposed to represent? Why did you choose it to look like that?
Do you not see my 3D program? Hold on. Let me go back. Hold on just a second. Let me change screens. Can I change? Let me change to my other program.
I don't know. To me, it looks like somebody swung a tennis racket. Hit a ball way up.
Hold on, let me pull
it looks like a tennis ball.
It looks like a tennis ball.
The one I sent you looked more like Pac-Man. The one I sent you earlier today. Hold on, let me where's the share?
Yeah,
I'm gonna do a new share.
It was the Pac-Man sphere
boom
eating.
This is what I want to show you.
Oh, nothing changed. We still see this. Oh, there we go. Now we see it. Yes.
Okay, great. Do you see the square around the circle?
No. Okay. Oh, that's where.
Yeah, you have. Okay, now you have a different projection.
But, right. So what does square represent?
It's your parabolic.
What does this square represent?
Right. Yeah, it's a parabolic Earth. So
he just had to shoehorn in the Bible where it said it. The 4 corners.
Oh, 4 angels are standing on the 4 corners because it's a circle and a square, right? And that's why it's parabolic. Is because in order to make the Bible true, I don't need a flat Earth. I need an Earth that can be a circle and a square. And
you arbitrarily took the words of the Bible and said, I need a square and I need a circle.
Mm-hmm.
And that's what you've displayed here, just by taking words and, okay, I'm going to create a square and create a circle. There's no basis behind what they do
Yes.
or what function they serve yet.
Oh, no. I have answers for everything.
All right.
So if I put this into the sphere, I theorize that these corners are sticking outside of the sphere. So we cannot see the angels that are standing on the four corners.
Could we go there?
Earth, no, you know,
dude, I want to just go there and like hang out
when we die.
I want to go hang out there, and then
Me too.
And then is there an edge?
Me too.
Like an angel
I want to go
bar or
there.
something?
Is there an edge
No,
in the square?
There's no edge. There. I don't know about the square. There's a cornerstone, right? There's a cornerstone of the earth. I don't know about the edge, but I do think that the earth resets.
If there's an edge, I'm telling you, if there's an edge, all we need to do is sell tickets to guys to go there and whiz off the edge.
Good point.
We'll go into partnership.
Do you guys? Okay, I will stop right now. Do you guys have questions so far? I can answer.
Yeah, I do. I want you to get to the meat of what this reset line is, because you keep mentioning the reset line in all the conversations we've had, and I keep asking you what does it represent and how does it function? Okay, what is a reset line supposed to do here?
The reason why I have 5 dimensions is so I can stitch the earth together, right? Like I can fold a piece of paper, but 5 dimensions is going to be different than going from 2 to 3. You're going to have a lot more structure. I believe that's why 95% of the mass is missing in the universe and you guys' model. I believe it's in the 5th dimension that we can't see. So if you're able to fold 3D space like 2D space, and let's say I'm going from Santiago to Australia, notice I'm hitting the edge, right? But I'm going to come out the other side depending on where I hit the edge. When I look up at the sky, I'm going to be looking up from under the earth, right? Because it's a reset sphere. It resets in every direction. The only thing that you and I can access is inside of the earth that we inhabit. So if I want to go around the world, I'm going to follow the equator around the earth. If I want to travel around the world in any direction, if the ISS is going over the earth, it's going to be able to go in any direction and reset just like a globe.
Okay, but did you solve the problem with distances? Okay, between cities, between countries.
Can I tell you, Gary, I'm not a cartographer. So what I did is I took the best map that I believe adequately represents the Earth as far as what we see in the sky. So this is based on like celestial navigation and being able to make the sky match. As far as the map, this is a Mercator projection that I got off the internet.
That's not a Mercator.
Yeah, it is. It's not. This is not.
What is that, Mike?
I don't know the name of that one offhand, but I've seen it. That's a popular one on the FlatEarthSociety.org website.
Oh, cool.
Tom Bishop uses that.
But is it again? That scale is a problem, right, Mike?
Yeah. So Chris, if you see where New Zealand is, like that way of Australia,
that's north.
Yeah. Or sorry,
Antarctica.
There's
a reset. There's a reset.
So if you go that way from Antarctica,
that's north.
You cross New Zealand, and if you keep going that way from New Zealand, you wind up at the North Pole.
Yeah. No, because this is south, right? So this is the edge. This is south of New Zealand, right? You're looking at it wrong. So
start at Antarctica at the South Pole, and then go this way.
North or south?
On your map, this direction. So everywhere, when you're at the South Pole, every direction is north, of course, right? So that's why I'm being specific, right? Go this way, and you cross it. New Zealand.
So if I go keep going, way, I hit the edge,
and then you Pac-Man up to the other side, and you hit the North Pole.
This is the South Pacific, absolutely. Now the edge. The reason why I have it centered like this is because I believe this is the way you triangulate it. So if anybody is a cartographer and you're into flat earth, everything in the center, and then on the outside you have a circle. And that circle of water is exactly as big as I need it to be. Go ahead.
Chris, I can tell you with 100% certainty, there are no flat earth cartographers.
Yeah.
You never, well, if you're a cartographer and just want to have fun, this is the way you would triangulate a flat Earth, because
There
the
is
circle
that
of the
song.
water
There is
is
that
as
song.
big as I need it to be.
Cartographers just want to have fun. I think it was Weird Al that sang it.
So Chris, the $1 million question here is: do you have any mathematical basis for anything you just described to us?
I can replicate the sky. No, and I come back to you guys. Do you have any mathematical basis for dark energy and the things that you believe? Because in order for the
We have
heliocentric model,
observational, instrumentational data that supports what galaxies are doing with regard to their gravitational attraction and how the stars within them are supposed to affect their gravity, collective appearance and dynamics. And I will tell you that those basically observations, along with the measurements that they make, are consistent with a force. Call it dark energy, but a force.
95% of the universe is missing.
Huh? What?
You're missing 95%.
No,
of the
85%, not 95%.
Okay,
yeah, the specific quantity isn't.
But a quantity, yes.
Yeah.
Yes. Okay, so you're missing mass. And what I'm providing is extra structure in the form of mass, because when you go from the second dimension to the third dimension,
you just introduced something. You introduced something on your own that says, I'm going to account for it. I'm going to call it X, and that's going to be it. So
that's kind of like what the scientific establishment
energy is accounting for. What do you call it, Fred, or whatever you want to call it? It's still something we have to define and account for. You're doing it in a different way, but you're introducing things that account for your effects. How you can describe a globe being a globe in appearance or perception by introducing these concepts that but you have no mathematical basis for it. And that's where
Neither do you, because you have to have extra dimensions to make dark energy.
No, you do not.
How do you make it work without extra
dimensions? You're
dimensions?
calling a dimension is not necessarily true for dark energy. It's not a dimension, it's a force. It's an entity that may be at the quantum level. We don't know that yet. We don't know enough about it. But we do know
have a valid model.
That its effect is observed and measured. Am I correct, Mike? Its effect is observed and measured.
Yeah, it is a placeholder. So if you go back to, for example, neutrinos. So when they were doing high-end particle physics work, they're doing these measurements. They discovered that there's some small quantity of energy missing. Nobody knew what it was. They reviewed all of the experiments. They reviewed the math. They went over it. They said, no, it doesn't matter how we do it. We're not making a mistake. There's a small amount of energy missing. Somebody said, well, let's just guess that there's another particle, and it is where this mass is. It was a guess. There were other guesses. That was one of them. Fast forward a few years, and they determined that, yes, there are neutrinos. There is a particle. The other guesses were let go of, and the one that was the neutrino guess, the one that was a particle with a very small mass and a very small amount of energy, is the one that was then empirically confirmed. So same thing with dark matter and dark energy. It is a guess.
What does the Bible say about dark matter? It says men love the darkness rather than the light.
It says nothing about dark matter. That's not dark matter.
How do you know? It's dark. It's invisible. You can't see it. You can't contain it. You can only theorize it. So that puts me on the same page as you. I need extra dimensions. You need extra mass from something that you don't understand. So how do you know it doesn't work?
But let's look at backing for what you introduced. You take concepts and you say, I'm going to use this and it's going to explain it, but it has no backing to explain it. I mean, you explain it in words, but you don't give us any physical description of it, any physics behind it. Whereas
that's why I talk
observations
to you, Gary.
of the universal celestial objects have physics behind it, and that's the difference.
Gary, honestly, okay, so I'm not that smart. I have a great imagination and I have faith. I believe that the word of God is true. And I have prayed about this. I have thought about this. I have looked at this. And like I said, Michael, I don't think this is a salvation issue or anything like that. But I do think that it makes it easier when you're thinking about all of these things. I mean, did we come from a Big Bang? That's not logical. That's not likely. Probability doesn't dictate that. And if there's a God, God is not an alien.
Probability doesn't dictate that? That's not true. You
10 to the 164.
It couldn't happen in a billion years. It couldn't happen.
10 to the 164 cannot ever happen.
Just because
it could have happened over couple
just
billion
because
years.
It's a big number doesn't
it's
mean
a huge number.
Yeah, run the actual, like, from beginning to end probability, not just look at one big number and say it's too big,
Right.
Well, there are 300 proteins that compose us. That is the probability for one. So it becomes exponentially hard. Sure, I could put a petri dish with all of the amino acids necessarily to form it, and I might form one in 1 second. But based on probability with a number like 10 to the 164th, you're not going to be able to create 300 of them that compose the human body without a creator that's doing this. And there's so many other things. That's just proteins. That doesn't include the mechanism of the cells and all of that other stuff. So
okay.
probability.
Chris, I'm not going to debate that because, I'm a person of faith too. I believe.
Yes.
Okay. The difference is I believe science is a tool that we are given or we've developed with our brains because we have that capacity to uncover things, to discover things that are intentionally there. I mean, we've discovered things. I don't believe anybody's lying to us. I think we have scientists who do real science. And that real science has explored our world, our domain. Now, whether our domain is a physical domain versus a spiritual domain and the two are separate, we can have that. That's a theological discussion. But I think there is a separation between the physical world and theology and the.
But if you say that, then the Bible.
And that's where I think the big difference.
So how can you have theology when God says that he put the sun in the sky where we could see it on the fourth day? How can you have any kind of theology associated with a book?
Because the fourth day is an interpretation of that mindset of what they see, and they say, well, gee, I have no science to back it up. I don't know what science is in this millennia time frame that I'm writing this literature and getting inspiration or whatever it was. They made a best guess at what they saw. I mean, this is the observation of the human being at that time. Now science comes along and you evolve methodology and you have tools to explore. You suddenly get a lot more knowledge, okay? You correct things over time. You couldn't have possibly done back then. Now people are going to argue and say, no, the Bible has to be right. It was written by, well, that's where, we get really hairy on what do you believe? Okay, what do you believe versus what do you know? Okay, and I go by what we know as versus what do you believe.
But you don't know, Gary. You just admitted you don't know that it's a theory. Like you guys are holding everything together with an invisible force where 85% of what you see doesn't exist.
No,
how do you explain
it's not that it doesn't exist. It's we can't observe it. It's not within our grasp with the
Maybe
tools we have. Just like millennia ago, we couldn't observe stars at the magnitude that we can now, at the granularity with the light, with light being received and analyzed like we can do today. How do you think we learn stuff? I mean, do you honestly think we could have built a cell phone back 1,000 years ago? Of course not. We didn't have technology. We didn't have
careful. There are some flirts that think there were laptops back 2,000 years ago.
There could have been.
There were pans,
to be honest.
No.
Stone pans.
I mean, they did build those big things all around the world somehow.
Those big things.
There's a lot of those big monoliths and stuff. I mean, how did they drill laser precision holes?
It wasn't laser precision.
All that stuff. Yeah, there is. Okay, so
but anyway, back to your model. We're looking at a lot of concepts here. You're throwing them out, and they don't have a foundation that I can see. I mean, there are terms you use, and there's concepts you.
I have the map full size on the screen here for you, Chris.
What map? Oh, I don't see it.
Your map. Your.
Oh, yeah. Okay, so
your bipolar
questions.
maps. So question, if you are on the equator, you're in Ecuador, on the west coast of South America, and you go due west, that distance from Ecuador there across, it's like the scale.
That's why the circle is in the water. Well, I what I did, Michael, is because it's a parabolic Earth, and I think that flat Earth flat earthers could fix a lot with a little bit of convexity. But because it's a parabolic earth, a shallow parabola,
Yeah, but
I
that
wrapped it
distance,
around
though.
the ball for proof of concept. Well, the water is the reset line. So that's why I have everything centered in the middle. That's what I'm saying. This is how you triangulate a flat earth map, is you put everything in the middle and the circle is inscribed into the water, right? Your reset line is in the water itself. So if the equator isn't quite this long, well, the reset line is here. If it's a little longer, then the reset line is here. So it really helps the triangulation, because I can go any direction outside and the distances are going to be exact.
How are the distances exact if this map is not this? I mean, it doesn't represent true.
This is a Mercator projection. I know Michael disagrees with me, but it is. And it was
I'll look up the name of that projection.
Yeah, it was meant to make like what is the Peters map called? What's it called? The Peters map?
Gauss-Peters.
Gauss-Peters, yeah. So it's kind of like that map that was meant to make it Greenland more accurate. Because on a Mercator projection, we use Mercator projections for navigation for years. But the problem is, go ahead.
If I may ask, there's two ice areas. The north, well, we call the North Pole, the Arctic. But you also show Antarctica on this map. So clearly it exists in both places. Yes. What in your concept here would define why you have ice in two specific locations like that if it's not a polar region like a sphere
because look at the path of the sun. So if I look at the path of the sun at the Tropic of Cancer, it's like this, right? If I look at the path of the sun at the Tropic of Capricorn, it's like this. So at the tropics, I would have a 24-hour sun in Antarctica. I would have a 24-hour sun in the Arctic, but the sun 23 degrees south or 23 degrees north of the equator, the angle of that sun over this Earth is not going to be, and remember, in the model, all of the mass is below us. So the sun, the moon, all of the stars that are traveling along the ecliptic are traveling through the same gates of the sun. So they're traveling straight. The circumpolar stars, right? The portals.
The portals.
Portals.
But yeah. How long is the sun in the portal?
It doesn't set in the portal. The portal changes the direction of the sun.
So
there are 12.
It's like the Pac-Man portal.
Yes. There are 12. Exactly. There are 12 gates. There are 12 windows. Inside of each gate, there's a total of 144 positions of the sun in the model. So there's 72 this way and 72 that way, which is pretty much what we see on time and date. I have not measured the sun, Michael. I mean, that's an experiment that I've always wanted to do to see exactly where it rises and sets like every day, but that takes a lot of time, I mean, that's kind of you got to really dedicate yourself to do that. But on time and date, if you'll notice, the sun will stay in relatively the same position for 3 or 4 days before it continues to move. So in the Book of Enoch, which is where the model comes from.
It's a sine wave relationship because the Earth's a sphere. It makes sense.
Or it's this. This is exactly like your sphere. It works exactly the same. There's no difference. It may not be a perfect map, but the concept, that's what I'm doing it for, is the concept.
That projection you're seeing there is the Lambert azimuthal equal area projection.
Okay. Layman's terms, I've never heard of that.
Well, on the wall behind me, I have the Lambert conformal conic projection. Lambert was the name of a guy that did map projections.
So does that projection retain correct scaling, Mike?
It's really close from what I've seen.
No, the scale is drastically wrong.
It has to be exact.
Well, the equal area, yeah. So I think the area is equal, but look at Australia. That's not how it's shaped.
But I have a reset line. So if I go this way, I'm going to come this way. And if it's not as convex, Australia is going to have a little bit of a different shape. And I know you guys are going to go to the Himawari satellite and say, hey, look at Australia. But your globe math is wrong. And that's something that I wanted to ask both of you, because I already asked you, Gary, and you weren't able to provide an answer. I don't know if you saw my question or not.
No, maybe I did not.
Okay, you probably didn't. So there was a typhoon in the south of the equator here called Typhoon Tip. typhoon tip was 1,385 miles across from edge to edge. So if I use Earth curvature calculation, and this has nothing to do with the height of the observer, right? A storm cloud is going to follow the surface. So we're talking about the angle of the storm here and the angle of the storm here. But if I use your Earth curvature calculations and I measure the width of the storm from edge to edge, the 1,380 miles, I get a 238-mile drop from one side of the storm to the other. But if I take that same map and I apply it from the center to the edge in each direction, it's 59 miles, right? So if the storm, that's why I used a hurricane, because it's a solid object. It doesn't really have a center of mass. I asked Craig this the other day. He didn't give me the right answer. But where is the center of mass in a hurricane? Michael, do you have an idea?
The center of mass of a hurricane?
Yes. Where would it be?
It depends on the shape of the hurricane.
Yeah.
Would a
But
hurricane...
generally, it's going to be towards the east, west, north, south. It's going to be towards the middle. And then vertically, I don't know. It depends also on how you define the edges of the hurricane.
Yes.
Okay. So here's the conundrum. Again, if I measure the hurricane from east to west, it is a 238-mile drop. If I measure it from the center to the edge, it is a 59-mile drop in each direction. And the reason why is because when you're looking at Earth curve map, Gary, you and I have talked about this. You talked about it with me the other day. This is why I wanted you to come on, because I wanted to put you on the spot about this. If I have a circle at 45 degrees, which is considered a great circle by airline pilots, and I travel straight east along that latitude line, then the size of that circle, and you were right, Gary, because I redid the math. You were right in your original. I was wrong.
Oh,
so you said 17,000 miles, right? That was correct. It's 12,000 miles at 60 degrees. But at 45 degrees, the circle is 17,000 miles. At the equator, the circle is 24,901 miles. Right. So when we think about degrees and we think about the drop associated with every degree, if I'm traveling east or west at any latitude, the curvature of Earth is going to be different depending on what latitude. At 60 degrees, it's 12,000 miles, right? So if I'm at 60 degrees and I have a 12,000 mile circle, I'm on a sphere. So, I mean, the surface is, curving down and away from me. If gravity exists, it's curving down and away in every direction. The Earth curvature would change. And that's not what we experience at all. There's no explanation for this. And the reason why
would change? No, the drop rate in every direction is always
no. Because a degree at 60 degrees north, if I have a 12,000 mile circumference, a degree at 60 degrees north is only 35 miles.
You're just thinking about the line of latitude at that latitude.
It's a smaller circle.
Yeah, but
which
it's still
means
just
that it curves differently.
That's
It's
just
still
an
relative
arbitrary.
down.
It's just an arbitrary selection of to draw a line of latitude on it. We could put lines of latitudes and longitudes, or use whatever shape we want. It's just
That's fine.
arbitrary.
So I want to go back to the hurricane. Why does the hurricane not match globe Earth map?
You'd have to present a little better case on why.
I don't have
match.
enough information.
This is simple. 8 inches per mile squared. It's 1,380 miles wide. Michael, I mean, you've got a calculator there. I know you do your math whiz. It's 1,380 miles wide. 8 inches. Just use the simple formula. We're just thinking about the surface. So if I measure from edge to edge at 1,380 miles, I end up with a 238-mile difference from this side of the storm. We're talking about the angle. Now think about that shape. That's crazy because the storm clouds are only 50,000 feet
Why
high.
does it matter how much?
Think about the shape.
Vertically. No, why
That's
does
insane.
it matter?
Well, for one, it matters because your math doesn't work. That's why it matters. Because
How does
again,
that not work?
because the drop, so the surface is the same.
The
Let's
shape
say I
is like
center
this,
it, right?
It's just like that.
But there's drop from the center because it's 1,380 miles wide.
Yeah.
And
Okay.
that drop is 238 miles.
Whatever. Okay.
Okay. If I measure from the center, it's 59 miles. So from edge to edge, according to Earth curvature calculation, the hurricane is going to drop by 238 miles. If I measure from the center, it's only going to drop by 59 miles.
I see what, yeah.
Yeah, that's a problem.
No, it's not. You're just doing the math wrong.
Oh, then fix it for me, because I've been trying to fix it all damn
Go ahead
day.
here. Go ahead. Let's explain
You're you're just, here's the, forget anything about the shape of the earth. Just take a ball. You can draw a circle on a ball.
I want the map. Come on, where are the maps?
You're the one making the claim. It's on you to do the
maps?
math, not me. But
okay, well, I already did. I'm telling you what it is. From edge to edge, you can verify it if you'd like. I've already done the math. I have a good memory. From edge to edge, 1,380 miles is a 238 mile drop. From center to edge, it is a 59 mile drop. So let's pretend that this is a ball, and I am traveling. I have a hurricane that's covering this much of the surface. I think it was 21 degrees, Michael. You and I talked about it. I don't remember exactly what, and I'm not good at math off the top of my head. I need a calculator.
I believe you.
So if I'm measuring from edge to edge, this edge is 238 miles higher than this edge. If I measure from the center, I'm looking at the same shape as far as the curvature of the earth, right? But I'm not getting the same measurement. And the reason why is because it's based on the tangent, Michael. You're a math guy. If I have a degree, my degree is not just going to go in one direction.
Yes, okay. So you have, all right, you want to stop your share for a second here?
Yes, here, I'm done for right now. You guys can go ahead and ask questions or whatever. Right. I'll answer anything. Go ahead. I'm sorry about that.
All right. So you've got, let me get a straight edge here.
Don't forget gravity.
Well, this is just geometry. There's no gravity involved in this particular part. So you've got the center of the hurricane here, right at the top, right? And then you're like, oh, you've got the drop on this side and the drop on this side, right? And you're asking about how come that, when I add these two drops, is different than when I add the drop from one edge to the other edge, right? That's what you're asking about. Okay.
Right.
It's because that's just not.
You're forgetting gravity.
Gravity's not.
Gravity's always putting you at the top.
Just geometry.
That's why I asked you where the center of mass is. The map doesn't work for the globe. It does not work for the globe. I have thought about this more than anybody else, right? And people will assume that, oh, it works. It's a globe. It's got to be a globe, but it doesn't work. The math is wrong. I'm not saying your globe is wrong. I'm saying the math is wrong because I'm not considering
that you're doing
surface. So I'm just using Earth curve calculation. So let's look at it this way.
Don't do that.
If I'm measuring, if I'm going from here to here, I'm traveling 6,200 miles across the surface and I'm dropping 3959, right? Now, because of gravity, I'm not dropping off of a radius. I'm dropping around a sphere. I'm dropping around a center. So if I do the math that way, over the entire surface, I'm dropping down and away in every direction, 15,836 miles over 24,901 miles traveled, right? So 15,836 mile drop over 24,901 miles. If I split that sphere into 360 equal sections and I put my frame of reference on the right side of the ball, because of gravity, everything's going down and away, then Earth curve math is way off. It shouldn't be based off the radius. It should not be based off the tangent. It should be based on the entire sphere, talking about the actual curvature. And if I'm wrong, then the hurricane should match your Earth curve math.
So here's the problem, Chris. And for some reason, no flat earther can figure out how to do math on a sphere other than the one tool that they have. So when you have your only tool is a hammer, every problem looks like a nail. And that's what you're doing. You're using the hammer to try to screw in a screw. And you're using the hammer to try to, when you should use a pliers. And you're using a hammer when you need a saw. Okay? So 8 inches per mile squared is not the only way to describe the mathematical geometry of a sphere.
Sure.
And
well,
the drop
you explain to me how to figure it out.
I'm not going to give you a math lesson right now.
Oh, I know.
If you want, I could prepare a lecture for you. But it would be better if maybe you just spent some time on Khan Academy and watched some of their videos.
No. You're not going to do that to me. You know Earth curve calculation. It's a sphere. Every degree. So let me ask you this, Michael. What is the difference on a sphere between 1 and 2 degrees and 90 and 91 degrees as far as the shape of the degree?
It's putting degrees on it. You can have any degree be 0, any degree be 1,000. It doesn't matter.
What is the difference between the shape of the degree? Every degree has the same exact shape all the way around the surface.
Yes, so you can.
So to correctly,
the surface curve isn't calculated in a linear fashion. I think that's what we're getting at. It's not a linear calculation.
You're looking through from point A to point B. The surface of the Earth should curve the same in every. So let's do the math.
Not from the starting point. Not if you start at a particular point and calculate all the way around to another point. It's not a linear.
You guys are wrong about this. You're wrong.
Chris, you're the one that you are the one that said you're not good at math.
Then explain it to me.
All right. Hey guys, Michael and Chris, I'm sorry, but I have to depart now. I only have this much time.
Spend
with you guys.
Gary, can we do this again? Like seriously, because you are my favorite person over there in Flat Earth Science Debate. Really, I love talking to you. You always have great things to share.
Okay.
Yeah, no, you are. I like talking to people like yourself. I don't want to talk to somebody who doesn't know what they're talking about. I want to talk.
Well, there's plenty of guys on our side who really have a lot more knowledge than I have. So, in fact, some argue.
But you're my favorite.
Oh, well,
I know.
But I want to thank you guys for having me on. Both of you.
Thanks for coming by.
Thank you, Gary. I appreciate it, man.
See you guys.
Yes, sir. Oh, that sucks, man. I want to talk to him more. I like that guy. He's cool.
All right,
he's a great dude.
I gotta fix where you are on the screen here for a second. So, all right. So let me try to put it in a way that makes sense. But
sure.
You're way off to the side of your camera, by the way. Whatever you want. There you go. That's a little better. Got to get everything, the staging correct. All right. So what you're doing is you're taking a distance from one position and going both directions, and then there's this drop that you're doing, which isn't really a useful necessarily way to do it. And then you're saying, well, let me shift my point of reference over to the far side.
The point of reference should always be the same. It's a sphere.
But you shifted your point of reference. You went from the center of the hurricane over to the edge of the hurricane.
The shape of the hurricane is covering.
No, stop interrupting. So you shifted over to the from the center of the hurricane to the edge of the hurricane. That's your point of reference.
Where's the center of mass? Okay.
And then you did, I want this whole distance here, and said, well, that drop is different. That's your problem. That's you're using the hammer, the one tool that you have.
No, I'm not wrong about it, because if I take a sphere, it doesn't matter where I'm at on the sphere. If I'm up here and looking over here, from here to here, it's 1,380 miles drop.
I covered that. You went this way and this way, two ways at the same time.
No, gravity makes every degree the same.
I couldn't finish my
sentence. It's 15,836 miles. Go ahead, then. Finish your sentence, because you haven't given me any math to fix this.
You are refusing to allow me to finish my sentence.
You're talking about drop like I'm jumping off a cliff, right? I'm telling you every degree shifts my frame of reference to every other degree, because I'm always at the top of the ball, meaning there should be no difference in a hurricane from here to there versus, we're not talking about dropping to the equator. Right? That's not a drop. If I cut the middle out of the ball and I jumped off the cliff, I would have to fall 39.59. And because it's a sphere, I'm falling all the way around it, which means every degree should be dropping at the exact same rate.
Yes, the first degree from the center of the hurricane.
No, that's observation. That's looking from here to here.
Again, I didn't even finish a sentence.
I know what you're going to say. You're going to say, because I'm looking from here to here, if I'm dropping way down off a cliff. That's not how it works. That is complete BS. That's globe BS to me. It is globe propaganda. because you're not mathematically able to solve the problem of the 1,380 mile
Well,
wide
I'd
hurricane.
explain it, but you won't let me.
You're going to explain it as drop. Well, if I'm here and I'm putting the hurricane, no, the drop is if I reorient the ball, the drop is the same no matter what, because you're dropping down and away, which is why I asked you where the center of mass is. There was a point to that question. So we can move on to something else, though.
Yeah, you won't let
up.
me. You won't let me explain it. So there's no point in trying to explain it to you again. The
can
fifth
try.
time, you will jump in again before I finish my very first sentence.
I swear I won't talk for 5 minutes. If you want to talk for 5 minutes, go ahead. I won't say a word.
You missed your chance.
I'm glad.
All right.
I'm glad.
Lord Illuminous Pooh says bacon is 73% fat and very salty. Me too, bacon. Me too. The only light in Chris's eyes is from a monitor.
Yeah, I've got my room blacked out here because I thought that you guys would want to see me, instead of my room.
Yep. All right. So the problem is, all right, so you gave this map, but the distances don't seem correct. But this is the thing. Earlier today, Chris said that what he's doing will allow people to do celestial navigation.
Absolutely.
And he warned me that I should take down my challenge. Now, if I had $10,000 for every time somebody said that I should take down my challenge, because what they're doing will let a flat earther, or will cause a flat earther to be able to solve the challenge, I would have many $10,000. Yet nobody has. So the several people that in the past have said they're going to do it have not shown up with doing it.
Well, I want to show you how I would do it, and I would never take your money. And if you agree with me, then I'm taking your money off the table and you can donate it to charity. Okay. If you don't agree with me, that's fine. I fully do not expect you to agree with me.
Well, you've already started off with a not flat earth. So it's a little bit of a challenge there.
Okay. Right. Well, yeah, that is true, because you did say flat earth. You did. But this will work on a flat earth, because when I made this video, can I share my screen again?
Oh, yeah. Hold on. Give me a second to.
Okay.
To prep what you have.
I have it ready to go.
Yeah. Mine isn't ready. I had it prepped for.
Okay.
No,
you're good.
For 3 people, and now it's 2, so I have to get this little slightly different scene. So, jeez. Wrong one. All right, well, start explaining it, and then I'll tell you when you can show it. How about that?
Okay, cool. So I used my wife's makeup mirror. She has a makeup mirror that has the absolute perfect convexity. It's actually concave from our perspective, but it is the perfect concavity to show what it would be like to look through that sphere. So I don't know if you watched the video that I sent you yesterday, Michael, of looking at Venus along. I don't know if I sent you that video actually, but I was looking at Venus and Jupiter, and I was following the ecliptic all the way around to look at where they would be based on my model. Because when I look this way, I'm actually looking up from this way, right under the Earth.
All right, you can share the screen.
Okay, cool. So I use a parabolic mirror to replicate the sky. Let me mute my audio. So what you'll notice is a group of circumpolar stars, which is a pile of salt here. And as I move 5 degrees across the surface, or any number of degrees, the same width of the mirror, you've got to be at the exact right distance, but it's going to roll the other way. Let me fast forward it here a little bit to where I actually move. Okay, here we go. Right here. So I want to show you the way this works. We have one circumpolar motion, and I'm talking, so, I like to talk. But notice how when I'm moving back and forth, the sky is rolling the opposite way, right? I'm showing the salt. Hold on, where did I move? Oh, yeah, there we go. So as I'm moving, I can only see 50% of the sky no matter where I'm standing, right? And I'm using 2 piles of salt to represent that see-through sky. So the Earth is a little bit convex. I'm looking this way, but I want you to notice the celestial equator. You see the celestial equator and the ecliptic in the middle So if I come here and I'm in between, you see in the pile of salt, dang it. Hold on. All right, right here, YouTube, see, it's the government. They're messing with me. They're not letting me stop the video.
Yep,
Here we
definitely.
go.
Yep.
All right, so the
Betty at
ecliptic.
NASA headquarters, she's always messing.
Right, and notice how the ecliptic is shaped like an hourglass, like my Earth, right? And then you have the circumpolar motion here and the circumpolar motion here. So if I'm standing on the equator, notice where Polaris is in the center of that pile of salt, right? And then as I move south, as I continue to move south, I'm going to be able, and south and north is right and left in the example. But as I continue to move south, that other circumpolar motion is slowly going to come into view. And like I said, I had this experiment set up to where when I moved the same width across the mirror, the sky would roll the opposite way. So if I move this way, the sky is going to roll this way. If I move 5 degrees south of Polaris, Polaris is going to move 5 degrees towards the horizon. And it matches perfectly with the example that I do. And I can do this on a completely flat Earth. So, and if I was to follow these stars, so one thing that you're going to notice is the stars are not in motion, right? There are 2 wheels of stars. If I was to try to follow these stars, I would need the declination, the right ascension, and the hour. Now I want to show you something else that's really cool. So if I did this for the regular flat Earth map. If I am looking down, do you see the ceiling fan? Notice how it's turning, and notice how when I'm moving in time, when I can match the speed of the fan, I can stop that fan in time. We're not there yet, but look at it goes all the way around the circle. And eventually here, when it slows down enough, I'm going to be able to move at the same speed of the fan, keeping the same time of day at every point. The rotation is exactly the same on all points of the circle around the outside. So one of my theories is because God has taken, according to the Bible in the book of Enoch, there's a third of the earth missing. And look at that. See how the fan stays completely still in time as I'm moving around the circle? That's the way the stars would work around the circle, or a semicircle. Because you could also do a flat earth on a semicircle with a reset line with a big pizza slice taken out of the flat earth. And it also works the same way. So it is as accurate. The mirror, this is not a good example. I mean, it's not a great example because I don't believe the earth is shaped like that. I didn't put a lot of effort into it, but I did want to throw it out there to show that it is possible to watch the stars around a circle and for them to match in time. So I don't know if you want to take that $10,000 off the table, because I'm pretty sure that
I have no concern about it.
Okay, well, I would talk to somebody, because this is exactly what we see.
So the point of the
Do you
challenge,
watch the sky a lot?
just for reference, the challenge is
the sextant, right?
Well, no, it's the measurements. The measurements have been given; they've been done already by somebody, and you just use the geometry of the flat Earth, as Nathan Oakley says, to get the position of the observer, and then you send in that position along with the method you used to get it, so that an independent person can verify the method.
Okay.
And then I'll send another set of measurements that you've not seen before, right? Whoever it is, right? And the very same process must be done to get the position of the observer for the second set of measurements. This doesn't give you anything. It doesn't tell you distances. It doesn't tell you angles to the sun or to the stars. It doesn't give you.
The distances are accurate, though. Can I chime in? If I move 5 degrees across the surface of the mirror, the sky is going to roll 5 degrees the other way. If I move 30 degrees, the sky is going to move based on the size of the mirror and the distance. It's going to roll exactly 30 degrees the other way. And it's exactly the way the sky would work in this flat Earth model. And it fixes a lot of things. All of the mass is under us in this model. So when you look at the circumpolar stars, what do we do? Why do we theorize dark matter? It's because of the expansion that we see. Well, these circumpolar stars that are falling in the
dark matter
is
not falling. Dark matter is not expansion. Dark matter is
energy is expansion.
Galactic rotation. Dark energy is expansion.
Right. Well, dark energy is what the all-encompassing term. But The expansion that we see is those stars falling away and moving constant. That's why everything's red shifted, right? Because the sky is moving. People assume that the Earth is moving, and you see all this red shift, and it's like, well, why is everything red shifted? And they have explanations for it and stuff like that. But I believe it's because everything is moving, and those circumpolar stars are moving. They're falling away from us. And it just describes a lot of what we see without the globe. And globe map is wrong, like I showed you. So, yeah.
You didn't show. You just kind of claimed, but okay.
Told.
So if you measure an angle to a star,
Mm-hmm.
how far? Let's say the angle is 25 degrees above the horizon, above true level.
Mm-hmm.
How far are you from that star?
It's hard to say. I mean, it depends on. It's really hard to do parallax when you're talking about distances.
There's no parallax. It's just one angle.
A couple of years ago. No. Do you remember when Betelgeuse then? Do you remember that? And everybody was like, "Oh my gosh, why is Betelgeuse going out?" And they came out and said, hey, Betelgeuse might actually be 25% closer and 25% smaller, because it's really hard unless you can accurately determine the size of what something is. In this model, they can be billions of miles away because the surface of the sky is here, right? The Earth is here. I don't know how high that sky is. It can be really any height, but the surface of the sky is where it is. But the cosmos can be billions of light years. Like what we see, it's wrapped up in the fifth dimension. So, and in this model, I told you that I would fix it and make it to where you could go to the moon. I don't think we did, but it would be possible because of the way this works to go to the moon.
How far is the moon?
It could be 240,000 miles away. Although, if the Earth is not as convex as it is on a globe, the measurements might change. And again, a lot of it depends on the size. And one of the things I question about the moon, Michael, is I don't think that people lie to be liars, right? I'm not calling these men liars. I think these men are heroes. I've always highly respected anybody who is willing to, strap themselves to a rocket ship and go to space is a hero to me. But one of the things that I question is how difficult it would be in the 60s to calculate that perfect trajectory, because if you're off by just like 0.05 degrees, you're going to miss the moon.
Well, they constantly made corrections.
That was a hard problem,
Chris. They constantly made corrections.
Though. It's still hard.
Yes, it's hard, but there are smart people that were up to the task.
Yeah.
Have you seen Hidden Figures, the movie?
No.
A fantastic movie. I highly recommend it. You should watch it. It's really good.
I will. I'll watch it. Cool.
So you don't know. So the thing is, you said that the celestial navigation challenges, I should take it down, you said, but you can't tell me when I give you an angle to a star, how far that away it is from the GP.
Are you talking about how far it is, like how far away I am on the Earth? Like if I have a star that's 25 degrees, I'd be at 25 degrees. If it's 25 degrees above the horizon, I'm 25 degrees above the equator. That's simple.
No, stars can be in any location, not just one location. So
you've got to have the three measurements.
Let's say it's due east of you, and you measure the angle to the star is 25 degrees. How far to the GP of that star?
Well, I'd need to know the right ascension and the exact hour to be able to follow the star with a celestial mount or an equatorial mount.
You've measured the angle.
Are you talking about the Pythagorean theorem? I'm not really sure what you're getting at here.
We don't use the Pythagorean theorem. We use the Haversine formula, but
okay. What are you getting at?
I'm getting at it's important in celestial navigation to know how far you are from the GP of the star.
GP means
the geographic position, the point on the Earth directly below the star.
Oh, well, it depends on what star I'm looking at.
All right,
you have to know all three. Bubba. You have to know that.
Let's call it Bubba. So we're Bubba Joe. That's a better name for a star. So you measure the angle to Bubba Joe as 25 degrees. Mm-hmm. How far are you from the GP of Bubba Joe?
I would be minus 90. I mean, I'm horrible at math, so
in
25,
linear
80 degrees,
distance.
80 or
Linear
65
distance.
degrees.
Well, I might be back. Seems I am able to send data now, but some stuff isn't appearing. So I'll wait for the chat to say something. All right, back. People say it's back. For some reason, I got to refresh maybe my my live chat because that's not going. That is just crazy. Okay, I see you guys. I see you guys. All right, I got to get Chris back. So yeah, I reset my modem, and oh, I don't need mail. I need my Zoom. There it is. Probably just create a new meeting.
Recording in progress.
All right. He's only got 30 minutes left. All right. Well, we need to check the stream. Show us a cat. A cat. All right. Jeez. It has been a little flaky. I'll be doing stuff and then it goes out for a minute, 2 minutes. And then it's back. So you go to like, is Comcast down, or is it, down dot is whatever it is. And you don't see it. And like by the time I get there and report it, it's back. So but so all right, so he says he's coming back. Here is the Toonshine receptacle today. It's olives. It's an olive from Hy-Vee. And you can see it's the label's coming up. We just put it in the dishwasher. And then eventually there's no label left. That's how it works. Neat. Yes, I would love gigabit internet. Well, so he's coming back. He says he's got to go. Oh, need to change. So I made a new thing. I need to disable the waiting room. So there we go. Let me see if there were some super chats. I'll read a few of them while, so let's see. Mr. QTube, first name Fa, says, Mr. QTube awaits the derp. And looks like we have Chris back. Is your audio working, Chris?
Can you hear me?
I can.
Cool.
Yes. So yeah, my network went down. It's been doing that on and off.
I'm telling you.
It's Betty, or she likes messing with me. So, and now
Better, you think?
it froze again.
I can hear you. Can you hear me?
Yeah, I'm watching my stream, and it drops to 0, it goes back, it drops to 0, it goes back. So
Hey, I've got to get off of here anyway, but let's do this again like soon, because I love talking to you, man. And I'm not saying to everyone, if anybody can hear me, I'm not saying that I'm smarter than scientists or this is the correct model. Like I said, I've been working at this. I know it's not perfect, but it's a fun conversation. I enjoy having conversations about stuff like this, and I love talking to you, Michael. I mean, I bother you all the time, you know that. So, but yeah, I got to get off of here anyway here in a minute. But if you want to do your super chats and stuff, we can if we're still on.
Yeah, sure. There were a few that came in. Some questions for you.
Cool.
If Stringfellow Hawk says the Bible is found in the religion section at a bookstore, not the science section. In the science section, you find books about the moon and Lake Titicaca.
Sure. I mean, you can take that perspective, but like I said, if you base it on probability, there's a God, and God, if you base it on probability, probably exists beyond the cosmos. And that is Judaism, Christianity, and Islam. That is the God of Abraham. So I think that the Bible is valid. And like I said, if you read the Bible in the right way,
somebody was
it's
asking you to calculate the probability of God.
Okay, so the way that I calculate the probability of God is if you take the probability of life, and it's impossible, basically. I mean, maybe not probability wise, but if you really think about it, it's very unlikely that there wouldn't be. So I can't convince anybody that God is real. I mean, that's something that somebody's going to have to come to their own conclusion on. You and I both worship the same God, Michael, but we have completely different beliefs. And that's because we serve a God who loves us no matter where we are, who we are. And that's really the point of God is love. God loves us, and we should love our neighbor, and we should try to please him by loving our neighbor and by loving him. That's the way I look at it.
All right. So you didn't have the probability.
No, I use the probability of life. Yeah,
right.
Probability of life is low without him.
Pat in the chat says, cute argument. Just curious, though, how do you determine the Bible's accurate and all that other religious texts are wrong? What was your method?
I don't necessarily think the other texts are wrong. Here's an example I'll give. The Tao, for example, is a lot of times referred to as the Word. There are 7 spirits of God in the book of Revelation, and there's not a lot of information given about the 7 spirits. I think to believe in God and that God created all things is the key to this. I think that is the everlasting gospel. And I know a lot of people will disagree. Whether you believe in a heliocentric model or you believe in a flat earth model, the simplicity is to believe in him, right? I mean, he's the reason we're here. So that's the way I look at it. I don't judge people based on religion or anything like that. God has had so much grace on me, man. I mean, I just don't have the ability to look at anybody else and say, hey, you're not right, because I know I'm not right about a lot of things. So that's the way I look at
it. Sorry, the car keys. I didn't have that. They're not in my pocket. My wife has to go pick up my kid. So, anyway, I don't have them, so they're somewhere out there. Well, here's another one from Many Karen for 15 shekels. He says, so many religions, the probability of one being true is low. So atheism is true. Exact same logic as yours. So you must accept his claim.
Well, I can't tell him that, his claim is invalid from his perspective. I only have my perspective. And like I said, the probability of a protein, can I give you the example of how improbable that is? There's a video out there, and it uses an amoeba traveling 1 foot per year across the universe, carrying 1 atom at a time, all the way there and all the way back, 1 atom at a time. That probability allows for the creation of the entire universe, 1 atom at a time, 56 million times. So that is how improbable it is for one protein, the 300 that compose us. I think when you look at, like I said, the things we can watch decay, I think these things that we see are very old. I believe that the earth could be very old. I don't think that we understand how to age things properly. But 15, 20, 100 billion years at the most doesn't give you nearly enough time to evolve life. There must be, maybe God is an extra dimensional being, which he is. Go ahead.
Well, yeah, that certainly is what a lot of people think, but you didn't actually do the math for that. So, I mean, it's just a big number. Therefore, you think it's not enough. But John Suffill says, can you explain how people living in Australia, South Africa, and South America can all see the same circumpolar stars on your
pretty
map?
Sure I just did. Well, I don't have access to my map right now, but yeah, if you look at my map, then you look at the mirror example I gave, how the sky shifts perspective because the earth is convex, right? So what part of the sky I'm looking at that line that is actually looking under the Earth, that's how it works. So those stars center up because of what I showed you with the parabolic mirror. That parabolic mirror replicates my sky. I matched the time.
Maybe you could build
an
actual model of like a physical model and test to
I
see
wish
if it actually works.
I wish I could. I wish I had that capability. Maybe you can give me some ideas on that.
How about this? It just works on a globe every time,
except for the math.
No,
and it's very unlikely.
Did
you watch my? Did you?
Oh yeah.
Debate with Craig the other night.
No, I haven't watched that. You did cut out for a bit there. No, I have not watched that one.
Okay, watch it. And next time we talk, we'll talk about it. That's a good subject.
Okay.
Gravity.
Confirmed. Ira Gwynn says, not too often I get to a live. Happy to be here. I'm glad to have you here, Ira.
Hear me?
Tesla Bitten, twice shy, says, public safety warning, kids, don't be like Chris, dogs, or don't do drugs. This is your brain on the flat earth. Chris, are you zooted?
Nope. I'm completely drug free. I've had 2 Stellas, but yeah, no drugs.
And do both Stellas know of each other? And does your wife know of this Stella? These Stellas.
Yeah.
I hope you didn't just cause a problem for yourself. Rubik's Cube Earth says all this bizarre craziness, rather than just admitting the Earth is an oblate spheroid. Come on, Chris, give it up.
Yeah, I'm not ready to give it up yet, but I am going to take a break from flat Earth for a while, and I'm going to encourage any flat earther to take this model and run with it, tweak it, do whatever you want with it. It comes out of the Book of Enoch. It's thousands of years old. So
when was Enoch written?
There are theories. There are different theories. 2,300 years for the most of it is pretty accepted, but I think it's a lot older than that. And the reason why is because of the cuneiform in Mesopotamia talks about the Epic of Gilgamesh and the eternal man who kept living for generations and generations while everybody else was dying. To me, that's Noah. I think that's written in cuneiform in Mesopotamia.
Why is that Noah?
Because he lived for hundreds of years after the flood. He's the only one who did. Everybody else died.
Is he also Gilgamesh?
I don't know. No, Gilgamesh is the... No, he's not. He's the eternal man in the Epic of Gilgamesh.
Noah is the eternal man in the Epic of Gilgamesh. And who's Gilgamesh?
Gilgamesh was the...
in the Bible, who's Gilgamesh?
Gilgamesh, I don't remember. I know Gilgamesh is in the Bible, though.
Okay.
The king.
I don't remember more than one king. You can't just say the king.
I don't remember, Michael. I honestly don't, man. I just been talking about cuneiform from Mesopotamia.
Okay. Alan Bupre says, Chris, why is everyone wrong except you?
I'm not saying I'm right. I don't know what shape the earth is. This is a model that was reconciled from the Bible, and that's why I'm in this, is because I believe the Bible is true. So I don't know if I'm right or not.
Your version of the interpretation.
Sure.
Yeah. All right. I was reading something from Truth Nerds. Delco's Man for $5 says you can very easily model 4 and 5D in computers. Just how we trick them into thinking in 3D. Do you know that it's when you do it in pure math?
I have thought about, okay, so do you see the I in my name there, the little I with the dot on it?
It actually says Mike on the screen because.
Well, okay, look at your name. You see that dot on the I? Where does that dot exist? I almost think that looking into a computer is like looking into extra dimensions. I mean, you can't really quantify what a computer is. Yeah, I mean, we can, but where does the I in your name exist in a computer?
Did you just say we can't
It's kind of like an extra dimension. It is.
No,
you can look at it that way.
No, you can look at it that way. The rest of us don't.
Yeah, you got to think about it right.
Okay. Okay. Pat the Chat says faith is for people who have no good evidence.
Faith is the substance of things hoped for and the evidence of that which remains unseen. So if you apply faith the way that I see it, you get the evidence, and that comes by way of the Holy Spirit.
Okay. So that, I mean, religious people don't claim that the Holy Spirit is evidence. So that doesn't, yeah, I mean, you just kind of agreed with them. Delco's Man says, after this, I feel like I've been breathing paint.
Cool. I'm glad that you feel that way.
Is it lead
Is that
paint?
a good thing?
Probably not. You wouldn't want to breathe paint because paint's a liquid and it's thick and coats things well. 3Ron says the delusion involved with this fabrication is on par with Mud Fossil University. Are you a fan of Mud Fossil University?
I don't know that I know who Mud Fossil University
don't go
is.
there. Don't go. No, you don't want to go there. It's jeez, you're Mini Karen. Who's Gilgamesh in the Bible? That's easy. He's Noah. I did kind of set you up for that. Well, anyway.
Hold on, Gilgamesh is not Noah.
Oh. What did Gilgamesh do in this Epic of Gilgamesh? He's the one that led the way.
Yeah, but
the flood.
The epic is not talking about Noah, I don't think. I think the epic is talking about somebody who was talking about Noah. Like maybe it was one of Noah's children, but I don't think that was Noah. Not in the Mesopotamian version.
I've always figured that Gilgamesh was Noah, but
it's cool. I mean, if that's fine with me. Yeah.
All right. RT96 says reset line is the new perspective. Yeah, you kind of just said reset line, and that gives you everything that you need to get out of every go to jail, do not pass go.
Right. Well, the Bible, I think, again, backs it up because there's an angel that is waving his sword in every direction, blocking our way to the Garden of Eden. So no matter what way we go, we can't get there. And that, to me, dictates a reset sphere surrounding the earth. And other verses, mostly out of the book of Enoch. We didn't really get to go, but if you go to parabolicearth.com, I'm going to finish that site tomorrow, and I will include all of the scriptures, the way the gates of the sun and the moon work, the way the eclipses work, all that stuff is included in this model. So,
are you going to include the Book of Giants?
No, I haven't really gone through the Book of Giants.
And the Gospel of Thomas?
No, but I like the Gospel of Thomas. I think it's a really cool perspective of Jesus.
And the Recipes of Marcus?
I haven't even heard of that.
Yeah, that's a good one. So Lord Illumina's Pooh says, can I get some of what Chris is smoking? Chris, they all think that you've got something going on there.
Honestly, man, I used to smoke a lot of weed. I quit smoking weed not too long ago. And I mean, that's just honestly the truth, but I don't do anything.
All right. Yeah, I haven't had any since that kid blew smoke in my face in 7th grade. Been clean since then.
It's not for everyone. It's not for me either.
Yeah. All right. Kango44 for $5 New Zealand dollars says, Chris, please explain how I watched Hunga Tonga volcano eruption from the Himawari 8 almost real time. Was it quickly made with CGI?
Oh, no, absolutely not. You can wrap. I mean, if you have Blender or any 3D program, you can wrap a live satellite loop. I don't deny satellites. I deny a globe. So it would be very easy to wrap any kind of loop around a globe that is in the background. That would not be hard to do at all.
But how do satellites work on parabolic?
Well, if the Earth is parabolic, gravity is an acceleration vector, and the acceleration or the velocity of the ISS is another vector. So if it works the same way because it's a never-ending parabola, I've always got that curve. If the Earth is completely flat, what I theorize is that the gravity vector is not strong enough for the velocity vector, and you can move out ahead of it.
The gravity vectors, which direction is it always? Are they all parallel or do they diverge?
No, they're all straight down because all of the cosmos. So if the Earth is flat, the Earth cannot just be a pancake, right? It's not just a thin pancake. It would have to be thousands of miles thick. Right. It would have to be thousands of miles thick. You also have the entire cosmos that would be included in the mass of the universe, in the mass of the Earth in this model. Everything is part of the Earth. Like when the angels were cast from heaven to earth, we see those angels in the sky. That's the way the Book of Enoch is telling the story, that a lot of those angels you see in the circumpolar motion are falling away because they're in the judgment. So yeah, I mean, it's perspective.
But you didn't explain how satellites work.
Which ones? Satellites work exactly the way, low Earth orbit works exactly the way it would on my Earth that it does on the globe Earth, because I have a surface that I'm continually falling around that surface as I'm traveling in a straight line, which would work the same way.
But you said that
if it's flat, okay, so if it's completely flat, which I'm not convinced that it is, but if it is, then gravity would work as a velocity or as an acceleration vector. The ISS is on a velocity vector that can move ahead of the acceleration.
But the reason why it works is because the constantly changing vector of gravity, they're not parallel on the globe. So the ISS is traveling orthogonal to it.
Hold on. It depends on if the Earth is flat. If the Earth is completely flat, they're going to be pulling straight down. On my Earth, you have the Earth's surface, which is kind of convex. So everywhere you're standing on the Earth's surface, you would have to have a gravity vector pulling straight down because of the mass below you. It would not be able to be, you wouldn't be able to, if it didn't work that way, you would be squashed. I mean, that's the way it would have to work. So it is very similar, and it's based on mass.
How does the ISS or a satellite stay up if it's moving orthogonal to the downward vector and all of the downward vectors are parallel?
No, on a completely flat Earth, I'm moving ahead of the acceleration of gravity. So if I reach a high enough velocity, I am no longer being pulled down by that gravity vector. On my Earth, it works the same way it does on a globe.
No, it doesn't. On your
Yes,
Earth,
it does.
all of the vectors are parallel.
No, they're not, because it's convex.
Well, I asked you, and you told me they were all parallel.
No, only if it's flat. I misunderstood you. Yeah, if it's completely flat, they would have to be. But if it's my Earth, then they're pulling. I mean, wherever you're standing, gravity would be pulling you straight down.
Okay, now when you calculate the velocity you need to use to be in orbit, it relies on the radius of the Earth. So if it's a parabola instead of a ellipsoid,
hold on,
and it has
let's think about this. Copernicus came up with his model. Copernicus came up with his model before Galileo came up with the idea of universal gravitation. So, or not Galileo, but Newton, my bad, got confused, Newton. So before Newton came up with universal gravitation, Copernicus already had the heliocentric model, and all of the assumptions of gravity were based on what we see in the sky. We know that on the surface of the Earth, you and I are going to fall at 9.8 meters per second squared. That is the gravity equation. It works great on the Earth. As far as the mechanism of it, if Newton came up with universal gravitation after Copernicus had already decided, he was biased. Because at the time of Newton, they had already accepted the heliocentric model. All of those motions were based on what we see in the sky. And as we look further into the cosmos with super galaxies and the way they rotate and stuff like that, Newton's law of universal gravitation kind of breaks down. So I think there are misunderstood and understood mechanisms about gravity. I don't think we've put the whole picture together yet.
Just saying you don't think so. I mean, you didn't point out any errors in it.
Neil deGrasse Tyson agrees with me.
No, he doesn't. He certainly does not agree with you in the least. Gravity is certainly mass attracting mass. The underlying mechanism for why of And this is true for every single part of science. The underlying reason why is still a question for everything. What causes electromagnetism? Photons. Why photons? It's an infinite recursion. You get to the end of it and you say, I don't know why this thing. Well, let's go one level deeper. Every single thing. Why does the weak force work? That's a great question. Let's go deeper and figure it out.
I don't think the weak force is really described that way, but the question is,
I
why is
intentionally
gravity so
didn't
weak?
describe it very well.
Yeah.
At all. I didn't actually describe any of the weak force.
Yeah, it's a cool concept. I love stuff like that though. I mean, I like thinking about especially quantum mechanics. So yeah, that's right up my alley.
Oh yeah, quantum mechanics. You did, yep.
We don't understand gravity on that level, so
You're right, but that doesn't change that we do understand it at a higher level.
somewhat.
Isla Baca says, Chris, according to your map, shouldn't we see both Polaris and Polaris Australis, that's the southern part, way above the horizon from the equator? This is actually better than the AE map, still wrong, and a fantasy, but cooler.
No, because it's the shape of the sky. Again, that reset line is the distance that it is above me. I don't know what distance that is, but whatever distance it is the surface that I'm looking at, right? So wherever that reset line is in the sky, even though the cosmos might be billions of miles below me, or billions of light years, whatever it is, I'm still looking at that surface, which is a distance that would allow for me over that convex surface to not be able to see both of them standing on the equator. All I would see standing on the equator is exactly what I showed you in the mirror. I would see the celestial equator, I would see the stars moving along the ecliptic, and part of the rotation on each side. That's all I would see. 50% of the sky.
I know you don't do math, and that's how you got to thinking that this actually made sense. But
I do math. I said I don't do math in my head. I'm very good at working out math if I have a calculator and the right equation. I don't do math when it comes to, thinking about it and just being able to, off the top of my head, like you can, say what it is. I don't have that kind of a brain.
Dude, I got this. I don't. I'm not doing stuff off the top of my head. Yeah.
Well, you
Professor
are better.
Phil Bill, why does he not accept the globe model of Earth? And bingo, all these problems gone, plus more.
I think this solves a lot of problems. I think it solves the gradient atmosphere moving. If it's not moving, it works better on a stationary Earth. There's so many things. I mean, you need to watch that debate with Craig, because Craig was wrong. And that's the thing. I mean, when you're on one side of the debate over the other, and you've got the pulpit, I mean, you can kind of say what goes. And if you got everybody following you, like, I mean, it is what it is. I mean, I come to these debates, I know what I'm getting into. But
all right,
what can I say?
Mr. QTube, first name Fat, says he's not good at math, but he knows the math is wrong. Question mark.
Yeah, I know math, and I just showed you how the math is wrong. The shape of a globe is what it is, and the drop should be the same in every direction. The problem is you're only basing it off of the tangent that comes off of the radius instead of looking at it in all directions. You need to center the degree instead of making the degree go one way. Because again, if I just measure the radius, I only have 39.59 of drop to the equator, but gravity is pulling me around the center of a sphere.
It's your hammer.
Hey.
And Alyssa, on point, says, Chris, this is year five geometry. How are you struggling?
I don't struggle. That's how I was able to create a model that works.
He has one tool. That's how. James Smith. This is good, Chris. He said, I thought about this more than anyone, but spending time thinking about something is different than spending time learning something.
Oh, this has been the best learning experience of my life. This is why flat Earth is good. If you are a flat earther and you take all of this stuff seriously, you're not going to ignore science. Why do you think I believe in gravity? right? I had to learn all of this stuff, man. I mean, I didn't know all. I'll tell you this, Michael. Before this debate, before this conversation, I literally thought that you could take a rocket and fire it straight up, and if you went high enough, that you would just float around in space. I had no idea about orbital mechanics, any of that stuff. I learned all of that stuff because of getting into the flat earth and learning how these things really work. So it depends on your perspective. It depends on what path you take, but it can definitely be a great learning experience. And it for sure has been for me.
Oh my goodness. I have an animal here, but it's not a cat. This is Jamil the guinea pig. He's squeaky.
I can't see you, Michael.
Oh,
I don't see your video.
Oh, I'm not sending it because your video wasn't good or your network's not good.
Oh, my bad.
You gonna squeak a little? No squeaks. He's super squeaky all the time, and now he won't squeak. He's got a little.
How long have you had your guinea pig?
This guy's pretty old, actually.
I love guinea pigs.
How old are you? He doesn't speak English. We think he's maybe 8.
Oh wow, that's awesome.
Yeah, he's okay. Thank you. So Earth is Life wants to know what's the different distance between Johannesburg and Sydney on your Earth, and how did you figure it out?
Do you want me to go to Google and tell you? I mean, it is what it is. So I said, it's proof of concept. I don't have a scale for it.
So that's the problem. When you have a model makes predictions.
Right. It's a concept. It is a proof of concept. I'm not a cartographer, like I said. I mean, I can't create a map. I wouldn't even try. But I think that that particular map is, if the Earth is flat, if it is one-sided, that is the type of one-sided Earth that it would be. I can't rectify the ice wall. And I've tried, because it's a lot easier. You don't have to have extra dimensions and stuff to rectify the ice wall. Maybe if you added convexity, it would work better, but it doesn't work at all.
You just add dimensions when you get into trouble. Lord Illuminous Pooh wonders, if a triangle has sides 1, 1, and 1, how many sides are there?
1, 1. Is that like a 1, 1, and 1? Would
yes.
Be a triangle has 3 sides. Why is that? Doesn't even make sense.
Oh, good, you got that right. Lord Illuminous Pooh says that you did not get the diss.
Oh, okay.
I don't know which diss you didn't get.
Yeah, it's all good.
Andres Eld says, congrats on coming halfway to the globe. There you go. You've got
it's what makes the model. It's what makes it work, and I really believe that's the way it works.
But I don't know how it solves any of your intended problems. This is what we do at work a lot of the time. We have a customer, they contact us, say like, hey, does your product do blah blah blah, these things, and then we jump in, we're like, oh yeah, we want to get in, we want to solve. And then, wait a second, what problem are you trying to solve? And we're like, oh, you just want this to happen. Yes, we can do that. We don't do it in the way that you prescribed, but we can solve that problem. So Chris, what problem are you trying to solve by proposing a different Earth shape?
The Bible says that the Earth is laid out on 4 corners, and it says that it's a circle. Isaiah said that he would toss you like a ball. He knew what a ball was. I believe it's inspired by God, and it's trying to rectify.
But a parabolic Earth isn't a circle. You didn't solve that problem.
It is a circle. A parabola is not a sphere. I can make a parabola a circle, and I can put it inside of a square.
But a parabola is not a circle either.
True. And I'm still working on the flat Earth. I'm still working on it. I'm still working on it too. And right now, here's where I am. I'm with the parabola.
If you keep going, you know what you're going to get.
Yeah, well, if I have to come to that conclusion, I will. But like I said, I mean, there's a lot. When you really think about the globe model, there are a lot of issues. And I've
not found any. All I found is people that don't understand it. But all right,
Well, I understand it pretty well.
Lord Illuminous Pooh says, I'm an agnostic, apathetic atheist. I don't know and I don't care, but I don't think there's a God.
Well,
At least he didn't end up saying he stays up late at night wondering if there's a dog.
well, I think that the fact that he started out with agnostic means he's leaning more in the direction that there is.
Okay.
He didn't start with atheist.
He included it in there, but that's fine. All right. Earth is Life says 1,000 years old flat Earth model, probably aged like milk.
It's actually a lot older than that. I think it's thousands and thousands of years old. I think it lines up with the ancient Egyptians and the Mayans and everybody else. Back when they had the technology to drill those laser holes and cut those blocks.
PhD Tony, he gets all technical. I love it. Does your guest
How come I want to talk to
GPS
him?
data? Okay.
I want Tony to come on here one day because I like that guy too. So
let's set it up. Tony's gonna need to take like 75 Prozac beforehand.
yeah, I know.
He's like,
It'd
what
be
about
fun,
satellite laser ranging data? Oh dear me. Yes.
Like
Hilo 1408 says, as a computer major, I can confirm that computers are not magic. Chris should avoid making claims about things he hasn't even tried to understand.
No, what I'm saying is that if I create an AI entity, let's say, inside of a computer that resides inside of a video game, I can make the AI, if it was possible, perceive the world in 3 dimensions when actually a 3-dimensional world doesn't exist. I mean, there's a lot of ways you can look at it. What I mean, and why I asked you where the dot on the I is because it's kind of ethereal. We know how computers work. We know where the data is. We know how the data is transferred, but
I can answer that question.
Something.
I can answer that question in many ways. I can say that there's a screen, there's pixels on the screen.
Right.
I can say that I.
That's not what I'm asking.
Yeah,
I'm
I can
asking
say that
where
the
is it?
I has a particular ASCII value. I can say that I is drawn on the screen using a particular font file, which is actually a program.
Right.
Right. I can answer it in many ways. None of them require me to go to extra dimensions.
No, but what I'm saying is we're looking into a 2D computer screen and can play 3D video games. We perceive it that way,
Okay.
Which is an example of the way that we might be perceiving things. We are only operating in 3 spatial dimensions, and I think there's a lot more out there than the 3 spatial dimensions that we live in.
Yeah, I mean, then we can walk through walls then and
Jesus did.
X-ray vision.
It might be possible.
Yeah, maybe if I do this, if I get different colors, can I get 4D instead of just 3D glasses? What
Maybe.
colors will give me 4D glasses?
Well, I mean, in 4 dimensions, you would probably have a lot more colors in the color spectrum.
I need a 3rd-dimensional color is what I need. That's just 2-dimensional colors. We're limited. Yeah. That's the limitation. All right. Steve 6464 says, OMG, people, read it before talking about it. I think he was maybe referring to this or the other one. This is the initial paper by Vera Rubin, about that ended up hypothesizing dark matter. And then he's saying, read about dark energy before talking about it.
Oh, I've read tons about dark energy. That's what I'm saying. All of the theories, if you look at most of the theories concerning dark energy, require some kind of an extra dimensional framework. Now, those dimensions might be wrapped up in really small places. There are different ways that it can work, but it requires extra structure in some way that we cannot quantify at this time. I'm not saying in the future they're not going to be able to prove it, but I look up to the light and I don't really care about dark energy. I believe that God exists beyond everything that we see.
People are wondering what book of the Bible says that Jesus walked through walls? I answered for you that it was Marcus's book of recipes, chapter 3, verse 17. Oh, the Gilgamesh thing. Yes.
No,
That's what
Jesus
Steve
walked
6
through walls after he resurrected. He walked. I don't remember what verse it is, but yeah, after the resurrection, Jesus walked into the room, right through a wall.
Ooh, Andrea Huddle has a good point. They are, to be clear, when we're talking about science, a theory is the other end. It's something that's been confirmed. You're talking about a hypothesis.
Nothing in science has been confirmed, or you wouldn't need dark energy to make your universe work.
That doesn't make any sense at all. That's not how
it
works.
Totally does. You're making something up, just like I am. That's why
you can confirm something. I can.
No, you can't.
I can confirm that this has a length. Here, I'll confirm it right now, and at the specific length. There it is. It's just over 4 inches long. I've confirmed its length.
Accepting something as true before you're able to prove it with experimentation or observation or anything else is not science, it's a religion.
That's not it. Oh, jeez. See, when you talk about proof in a very formal sense, that's not what science does. Delcos Man says we can break computers down to the atom's movement. So the opposite of what you said from someone who just dealt with fuzzy noise for neural networks.
That's cool.
So when you do your AI, what do you write it in Lisp or what language?
No, I learned in AIML, which is an old that's over at Pandora Bots. That's where I learned the language. I'm interested in making chatbots and an AI that can talk like a human. So right now I'm using Dialogflow, which is an alphabet company, Google, and they have an amazing machine learning algorithm. You can put it on a hybrid where you use rules-based plus machine learning. But I kind of agree with the thesis of Alan Turing that it's possible to create a robot or an entity that can have human conversations with less than 10 megabytes of a brain. I think it's possible. I haven't figured it out, but my AI is pretty good, and it only has a brain of 6.7 megabytes. So,
will you be replacing yourself with this AI?
It does have a lot of my personality, and the Zoaxis video game that I'm making, the card game, it is going to incorporate the AI into the game. So yeah.
Right. That sounds great. Delcos Man says you can read motor feedback on a KUKA arm if you have a very massive end effector and feel the pull towards the larger mass very slightly.
Sure.
I think he's talking about basically a torsion bar, mass attracting mass. Is that correct?
Yeah, I would love to be able to redo the Cavendish experiment. I think it was a cool experiment, and I would love to see it done, but I wouldn't have the ability to do that or the patience.
People have done it.
I know.
Blue Marble Science did it. You're not that far from Tennessee. You could maybe go see it.
Yeah, it would be cool to do.
All right. Delcos Man again comes in and says, ask him why he uses AIML in 2022. I used that in 2012.
Well, that's when I learned, was back in 2016 was what I learned on. And then I moved over to Dialogflow.
Okay. Why not Lisp?
I don't know Lisp. I've never learned it.
Do you like typing parentheses?
Yeah.
If you do like typing parentheses, Lisp is the language for you.
I will look at it. Yeah, definitely.
It might be a little older than 2012.
No, I said,
okay.
I think it's the randomness. You know, when you're talking about conversation with artificial intelligence, you don't want it to give the exact answer every single time. You kind of want it to be able to go down its own path. Humans don't. If we're having a conversation, Michael, and I ask you a question, you might choose to answer my question, or you might deviate, or you might bring something up that's related to it. Or if
you're talking to a flat earther on Facebook, they'll deflect every time.
Yeah, I don't. I love sitting there talking to you guys on Facebook. It's one of my favorite things to do.
Mute Donkey says, why not use a real language like C++?
Yeah, I'm a simple guy. Obviously, guys. I mean, you guys think that already. So
I
the
I like
simpleton
I
does what
like
the
Python and
simpleton
Java
does.
myself.
I do know Python, kind of.
Kinda. Crocophile Dundee wants me to ask you a question. Um, uh, what is 5 divided by 0?
Come on, man.
What?
Five divided by 0
Yes.
is 5.
5 divided by 0 is 5.
5 divided by 0 is 0.
Oh, it's 0 now. Which one is it? Is it 0 or 5?
If 5 is divided by 0, it would be 0.
Should I try it on here? What do you think is it gonna give me 0?
5 divided by 0 is what is it?
All right, here it is.
I've never divided anything by 0.
It's not gonna show up. When I hit divide, it gives a little beep. It says infinite result error. It's not defined. But if you take the limit,
Hold on, how does that work?
Infinity.
I've never tried to divide. That's crazy. I've never even heard that or thought that. Why? Because it's like 0.0000. How does that work?
Take five clementines. Okay. And divide them into 5 even groups of clementines. How many clementines is in each group?
1.
Okay. Now divide that into 2 groups of clementines.
0.5.
You have 2.5 in each group.
Oh yeah, okay,
Right?
yeah.
Now take these 5 clementines and divide them into 0 groups. How many in each group?
That blows my mind up. I have no idea. Can't do it.
That is a better answer than 0. That's why it's undefined.
Huh. Interesting. Never heard that. That's interesting though. Yeah, cool.
All right. Lord Illuminous Pooh says Octothorpe. Hashtag Octothorpe.
I don't have any clue.
We've got Andreas Eld for 56 says, how about a cylinder Earth viewed from the side? It has 4 corners, and from the top it's a circle. Well, it's a good idea.
I actually think the 5th dimension is kind of like the inside of a cylinder or the inside of a paper towel tube.
All right, here's a cylinder. Look at
Now
that. It's got 4 corners. Look at that.
Turn it and look at the inside of it. That is kind of similar to how I think 3D space is.
You should totally
together.
go with cylinder Earth. You're already doing Pac-Manning, so you can just Pac-Man all around here, Pac-Man all around here, right?
Yeah.
Then you've got you corners, circle.
The reason I do the Pac-Man is because of the angel. Like I said in the Garden of Eden, I think the Bible gives some real evidence for it, and the Book of Enoch, the angel Zotiel. When Enoch went to the Garden of Righteousness, he flew over the angel Zotiel in a certain direction.
Look, if you're gonna talk about like background fantasy stuff, let's talk about.
I don't think it's fantasy. I think it's truth.
Yeah, it is. Let's talk about the Silmarillion instead. It's a little better written, but let's keep going here. I think you should totally work on the cylinder Earth because that's what Bob Nodell uses too. So. Lord Illuminous Pooh says Yeshu is the ancient Hebrew word for Josh. Christ means the anointed one. I will henceforth refer to my real name as Oily Josh.
Cool. Well, I'll say something to that. Revelation 19, beginning with verse 11, tells us that Jesus Christ has a name that no one knows but he himself, and his name is called the Word of God. God said, let there be light, and he created the sun on the 4th day.
It took a while. Delco's Man for $2 says HMU. I'm currently working on NN with voice cloning.
Cool. That would be fun.
I don't know what NN is.
Neural network. But if so, it can take your voice. That I actually did that. I went to a company, I don't remember the company's name, but I tried to clone my voice and it sounded like I was a chipmunk, kind of. Didn't work very well. It was more high pitched than my voice and I sounded really weird.
How do you know it's more high pitched than you? You've only heard your voice from inside your head, not outside your head.
That's true. Well, in recordings and stuff, I was going to take my voice and put it to my AI, but it just didn't do very well.
All right. Stringer News 1 says, as usual, Gish was ridden hard and put away wet.
Cool. I didn't expect any opinion other than that. So.
Alyssum says 5 divided by 0, struggling with year 5 math concepts again, eh?
Yeah, I don't get 5 divided by 0. That's mind-blowing to me. It's weird to think about.
Right, what is the square root of 4?
2.
Okay, what's the square root of 9?
3.
What's the square root of 1?
I don't know.
What times itself equals 1?
Point. I don't know. 1. 1 times 1.
There you go. 1 times 1 is 1.
Yeah.
Very good. What's the square root of -1?
2 negatives make a positive, so it'd be. Is that right?
Yeah, -1 times -1 is positive 1. So it
right.
can't be -1.
1 times -1.
Yeah, but the square root means multiplied times itself.
Yeah, I don't know. I haven't looked at that type of math in a long time, Michael. I kind of stick to my calculator, and if I need to know math, I go to Google and I learn how to do it.
Well, to an electrical engineer, the answer is J. To basically everybody else, the answer is I, the imaginary number.
Okay.
There you go. Yeah, imaginary numbers are useful.
For what? Placeholders like.
No, it actually happens. It's used for coordinate systems. It's used for. It happens. I don't do it when writing email software, so I don't get into negative or into the imaginary numbers much. But they are we used them all the time in engineering, and I cannot even give you an example at this point. Hugh Jars has been a member for 13 months. Says, how can this guy listen to himself and think he's correct? He has zero evidence, just a bunch of things he wants to be true, but clearly aren't.
That's his perspective. I have an explanation for every question that anybody can ask me.
But how does your model predict the distance between Santiago and Sydney?
The distance is what it is. And if you look at my map, that ocean circle is exactly as big as I need it to be. That's why the ocean's on the outside.
If I take a ruler and put it on there and then go to your scale and measure it.
Measure it, yes, because the circle of water is exactly as big as it is.
It's your get out of jail card. All right.
It is, though.
Cretan Ball, who last week dodged a death threat. Cretan Ball says, all hail the king of Dunning-Kruger.
No, I don't have Dunning-Kruger because I know that I don't know everything. And I like learning. I like learning from you guys. I've told you a million times, Michael, you know, I think you're smarter than I am. I think Gary, the reason why I chose Gary to get on a debate with us tonight is because he's one of the smartest people I talk to in the group. I learned a ton from that guy and everybody I talk to. I learned a ton from all of you guys. So no.
You said, what did you say? Something a million times?
That you're smarter than me.
Okay. Look, Chris, I've told you at least 1 billion times not to exaggerate.
It's just true.
Yeah. Let's one more here. Amber Turd. Spelled T-E-R-D. Says Chris threw a globe at me and broke my nose, just like Johnny Depp.
Oh.
Have you been following the? I have not been, but
it's hilarious.
Ranty, who's auditing the absurd, has been, and he has a couple videos, short ones, like a minute long, 10 million views. That guy is
Oh
going
my gosh.
crazy. Yes.
I'm so glad for him, man. I love Ranty. I think he's a great guy. I really like that guy.
Yes. So, okay. Oh, Chris, you said you had to go. I don't want to keep you longer. Stella is probably upset. The other Stella probably is upset at the first Stella.
I might go get another Stella before I go to bed. But yeah, brother, it was good talking to you tonight, man. Michael, it always is. And I love these conversations. You know I do. And I hope we get to do it again real soon. I'd like to talk to PhD Tony. I'd also like to get on with Gary again. I'm really sad we didn't get to spend more time because that guy really, really is. I mean, he knows a lot of stuff. It's disappointing that he had to leave so early. So,
is there any way that your hypothesis can be observationally invalidated?
I'm sure there is.
Can your hypothesis be tested?
Yes. It can be tested that I can replicate the sky the way the sky works. And if the map...
but not
just
in a vague and rough way, in a very specific way.
Well, I've always said, okay, so from the beginning of me getting into this and trying to put this thing together, I've always said that it's conceptual because I'm not a cartographer. I'm not smart enough to put a map together. That's why I chose that map. I picked out of all the maps, I researched on the internet, and I looked for one that matched conceptually what I was looking at. And my idea of having these conversations is to stimulate the thought process of other flat earth proponents or other people who are just interested in this conversation to, think outside of the box and say, hey, this will work or it won't.
You're a cylindrical earth proponent now. We figured that out, Chris.
This
is yours.
I could go with any shape of the earth, man. And I told you, Mike, the reason why I'm in this is because of the people who just don't believe in God because of the Big Bang. If the earth is one-sided, God is the only option. And I believe it is.
Okay. We got one more. Lord Illuminous Pooh says, it's lucky Bruce Wayne focused on his fear of bats instead of the death of his parents, or he'd be back alley murder man.
It's kind of a good point.
Yeah, absolutely. We do have in an intermission, and yes, I have another stream coming up. I'm going to assemble a Lego orrery.
A what?
Orrery. Do you know what an orrery is?
I have no clue. No.
It is a model of the solar system, but this is just the Earth, Moon, Sun.
Out of Legos? You're gonna do that on the stream?
Yes.
Oh, cool. Interesting. Well, I might watch that when I go lay down.
Yes. So
might be fun.
There you go. Cool.
Well, guys, thank you. Thanks for having me, Michael, as usual, man. I appreciate it.
Yep. It certainly was. I ask all the time for a model, and flat earthers usually just send the AA map. So I appreciate that you have something else. So
yeah, sure. I hope we get to talk about it again one of these days, man. But like I said, thank you, and thank everybody for having me, and I'll see you guys next time, hopefully.
All right.
God willing. All right, brother. See you later, man.
We'll see you later, and we'll see everybody else after this ends.
I will be back. I'm going to come and watch your stream. Peace out, man. Thanks.
Right.